So here in this problem, we have 4 points that are coplanar. That means they lie on the same plane. And the position vector of these 4 points are represented by the vectors A, B, C, and D. So we need to show that this particular relation holds. That means we have the scalar dot product of A, B, and C, and that is equals to the scalar dot product of A, B, D plus scalar product of A, D, C, and scalar product of D, B, C. So this is a scalar triple product. So let us begin. Now for understanding purpose, so let's say we have a plane and this is 4 points with position vector A, B, C, and D. So what we'll do, we'll join point A and point B represented by the position vectors AB. Then we'll join AC and AD and we'll determine the vectors AB vector, AC vector, and AD vector. So let's do that. So we have AB vector. So this is defined as the position vector OP minus position vector OA. So this is simply going to be equals to B vector minus A vector. So AC vector will be equals to position vector OC minus position vector OA. So we have C minus A and AD vector. So that will be equals to OD vector minus OA vector, and this is equals to D vector minus A vector. Fine. So now what we will do, since the points are coplanar, so that means AB vector, AC vector, and AD vector. So these 3 vectors are also coplanar. So that means they are also going to lie on the same plane. And this is evident from the illustration. So if these are coplanar, then what we can say, the scalar triple product AB vector dotted with AC cross AD, so this value will be equals to 0. So what we'll do, we'll substitute the value of AB, AC, and AD, and we will solve this particular equation to arrive at this particular conclusion. So let's do that. So AB vector will be B vector minus A vector. So this is dotted with, so we'll have to take the cross product of AC vector. So that is C minus A vector. This is crossed with AD vector. So that is D vector minus A vector. So this is equals to 0. So now we will do, we will distribute C minus A with D minus A. With B minus A vector dotted with C vector crossed with D minus A vector crossed with D minus A. So this is equals to 0. So we have B minus A dotted with, then we will distribute C with D minus A minus, now we distribute A vector with D minus A. So this will be equals to 0. Now A vector cross A vector, so by definition it will go to 0 because both of them are parallel, and when 2 vectors are parallel, the cross product will be 0. Now we'll have, so what we'll do, we will distribute B minus A with each of the 3 terms by taking the dot product. So we will have equals to 0. Now if we consider the 1, 2, 3, 4, this is the 5th term and the 6th term, this will go to 0. This is the definition of a scalar triple product. So because we have 2 vectors here, A vector and A vector, that's repeating, and also here we have A vector repeating. So whenever we have 2 vectors repeating or the same vector, then the scalar triple product goes to 0. So now we are left with 4 values. So let's rewrite them. Now what we'll do, we'll keep this vector at one side and the 1st, 3rd, and the 4th on one side. So I'll keep B vector dot C cross A on the left hand side. So this will become B vector crossed with C cross A Now what we'll do next, we're going to change the sign of these two vectors on the right hand side from negative to positive. That can be done by using the definition. Let's say we have the cross product between two vectors A cross B. So this is same as saying negative times B cross A. So that means we can rewrite this equation as, so this will become positive B vector dotted with, so A cross B, that is D cross A. And thus similarly this will be positive A vector dotted with, so we have C cross D, so that will be D cross C. And the rest of the terms. So now what we can do, we can rewrite this scalar triple product in a compact form. So this will be B vector, C vector, A vector. So this is equals to B vector, C vector, D vector plus, now we know that our scalar triple product, the vectors are cyclical in nature. So BCA, this is the same as saying A, B, C. So it's because it is cyclical in nature. Now BCD, so BCD can be also written as D, B, C. Plus we have BDA, so this can be rewritten as A, B, D. And we have ADC, so let's keep it ADC. The whole reason I am doing it in this particular fashion, because this was what was asked to be proved. Hence, proved.